Okay, we'll go ahead and get started. Sorry for the delay. Today, the plan is to cover documentation, and we'll look at different forms of documentation from code comments all the way up to project documentation. And then hopefully at the end of class, we'll have time. I'd also like to go back and revisit the idea of generators and context managers. And we've seen a little bit of those ideas with the testing framework. So we'll kind of add on what we've already learned from PyTest. Okay, so documentation, what is it? It actually serves several different purposes. It can be your user's manual. It can be blueprints for how the software is laid out. It can be an advertisement, something that should show someone that they should use your software. Sticky notes, just things to remember later on. And it could even be something like a textbook. You're using it to instruct people on a particular method. And then we do have pros as well. So different types of documentation. First is code comments. These are inline comments, usually left for developers. Then we have doc strings, which is a way Python provides for us to attach documentation to different Python objects. And we have a README. This is usually a short file, but it's an advertisement, a poster for your software. And then project documentation, which we'll go through some ways of thinking about that and how extensive it can be. Okay, so a few things about inline comments. We talked a little bit about this with the style module, but that was several weeks ago, so we'll review a few concepts here. So comments are made on the same line as the code. If they're inline, they can also be made above or below. I'll show that in a second. But the thing here, the style guide suggests that you separate comments by 2 spaces. So notice how there's 2 spaces from the 1 to the hash sign there. Yeah.
What about if you separate it more than 2 spaces? Is it still okay?
It's okay. It's going to run fine, but it's not following the style.
It must be 2 spaces.
It should be 2 spaces. It doesn't. I wouldn't say it must be. Okay. So we use these sparingly. We try to explain why and not what. So for example, add 1 to width. What is this comment adding to the code? Nothing, right? It's just noise. Also, comments can mask other issues. So how could we fix this or improve this?
Changing the variable name.
Yeah. We don't want to just specify what X is in a comment. Let's just call it what it is as a variable name. Now we don't need the comment. Okay, so code blocks, these start with 1 or more of the hash signs. A single space follows each one of them. They can span many, many lines. They should match the indentation level of the code. Again, that isn't a must, but should. So here's an example. What we're doing here is explaining why we're doing something in a particular way. So it can take multiple lines to do that. That's perfectly fine. But again, we don't need to state the obvious. This comment here says loop over 0 to 9, add 42 and print, but the code is doing just that. So it's really not adding anything. Comments are also fairly important to justify something unorthodox that you're doing. And one common case is when your imports are out of order. Sometimes you need to do this though to avoid circular imports. So in this case, you would just document why you're doing it that way. Does everyone know what a circular import is? So if you try to import something in the wrong order such that your dependencies are another module that hasn't been loaded yet, you might find that the module doesn't have a particular attribute or something you're looking for, and it will just throw an exception. So yeah, usually it's a sign that there's something potentially that can be improved in your code. If you have a bunch of these circular imports and it becomes really fragile, you might want to think about restructuring your code so you don't have that. Okay, so comments on attributes and variable meaning, and importantly, units are a good thing to put in a comment there. Here's a few comments in the wild. So I took this from NumPy. So right here, this is a record class, and then it's explaining essentially what the following lines are doing because it's not obvious. it's not obvious what, and it's not obvious why. So let's explain there. This is a good example. So occasionally there will be a reason you're doing something that could be quite long, and you don't want to write half a page of comments here. So it's good practice just to reference a GitHub issue where you've discussed it more. And so you might have just a little summary here, and then whoever's looking through the code can just go to that issue and read more about it if they need to. Okay, so let's do a quick understanding check here. How can we make this comment better? I'll scroll over so you can see it.
Was getting too long.
Before it's getting too long, yeah, so we could potentially add an extra line here. This is actually kind of a narrow display window. Normally, this would be fine to fit on a screen. So yeah, it could be an issue, but I don't think it's a huge issue here.
The inline and to frequency that doesn't be there, and perhaps something that hurts as like a frequency that.
Okay.
I think we can just
Delete the comment.
because so it's just saying what the code is, not what.
Yeah, I'd agree with you, but I'd add something. Let's what we have here is actually a function. So we're creating a sine wave. We should just pull this out, make it a function, and then we add a good name, make sine array. Solved our problem. And now we have a bit of reusable code. Okay, any questions about comments in code before we move on to DocStream?
That's about the styles of use when they create a function and they're like, oh, we're gonna list all your inputs, all your outputs. I know some people are really strict about this, some not so much.
Yeah, so the place to do that is in DocStrings, and we'll cover that next. Any other questions? Should be pretty simple, right? Okay, so docstrings are a little bit different animal. These are actually part of the Python language, whereas a comment will not get, Python won't do anything with it, it just skips it. A docstring, though, actually gets attached to whatever object it belongs to. So in this case, we're creating a docstring for this function called recombobulate, and that is actually going to be something that we'll be able to access through the recombobulate namespace. Okay, so other tools might use this to introspect, maybe for building automatic documentation, for example, or to introspect some of the descriptions of the variables. I've seen that happen before. So this actually is kind of different than a comment. I just told you not to say what the code is doing, but the docstring is actually the right place to say what the code is doing. So a description for someone who might want to use this function, everything they should need to know to do that. And we'll talk about how to use document our inputs and outputs in a second. Okay, so if you wanted to access this, you would just do recombobulate dunderdoc, and then it has that string stored. So one thing we looked at in the functional module was a decorator called wraps. So when you do a decorator and you want to transfer metadata about a function that's being wrapped, this is essentially one of those things that's transferred. It's going to copy the dunderdoc to the wrap function. Okay, so let's talk about an ideal docstring, and I'm calling this public. We talked about in the style module how if you put an underscore, that kind of marks something as private. These don't really need to be documented quite as well because users of the library aren't typically interfacing with them. It would more be just the developers and internal tooling. So these are going to start with a single line description. And this is pretty important because a lot of times you'll collect short descriptions and put them in a table. If this was multiple lines, then you wouldn't be able to make a table of these for nice display. Here, you're going to want to describe the input parameters as well as the output parameter or parameters when needed. And I'll show you when it might not be needed. And then it's also good to provide an example. I know whenever I'm looking at how to use a pandas or a NumPy function, I go to the documentation page and I just scroll down to the examples. That's the first thing I want to see. So those are quite useful. All right, there's several different ways of doing this. There's style NumPy style, which is what I tend to prefer, and I think it's the right choice for scientific programs. There's also standard REST. This is more the style that OBSPy is written in. If you've seen the source code, it has the like colon param type, all that. It's just a little bit less readable in my opinion than NumPy. Google has a style as well. And I really wish we could just use Markdown here, but that isn't really common practice, maybe someday. So most common, NumPy is the most common for scientific machine learning codes. I think it's the most human readable. There's several sections that are just separated by these dashes, and I'll show you an example here. And then you can also use doctest, which we'll talk about in a moment, which is it's kind of a way to put some testing into your documentation. Okay, so let's look at a longer doc string here. So the parts of what we have, we first have our one-line summary of what this function is going to do. And then the next section is going to be parameters. So notice how with these sections, we have the underscores that are the same length as the section name. And here we're describing each of the inputs, and there's a colon there to separate the name from its type. So we're assuming there's some kind of Bob class that we're using here. And then there's some kind of bits class. I don't know. So then we'd also specify that it's optional if it can be none. And that's how you do it in the traditional style. Here we have return, so you describe what the return object is, and then some examples. And I'll get into how to write these examples more later. So for now, we'll just note that you can have examples there. All right, so a newer style though is, since Python, I believe it was 3.4, they introduced type hints where you can add annotations to your variables. So rather than trying to describe what its type is in the doc string, you can just add it to the function signature at the top here. So notice how before we just had Bob, here we have its type, and the same thing for the bits argument. And then we don't really need to repeat ourselves. So when we get down to this parameters, we can just have the name here. And then I skip the output because this specifies what the output type is. And if we don't have any additional information to add about it, there's really no reason to have that section. Okay, any questions so far? All right, so here's an example of doctest. So how this works, I don't have an implementation for this factorial, but let's assume it's correct. We start off with this one line that's going to explain what the function does. And then here's some examples. So we have these three greater than signs, and then we're going to put some code that's going to be executed there. And what we put under it is going to be whatever the terminal would spit out as a string. So notice how we haven't defined a variable to put the output of factorial in. So normally if you're typing this in the REPL or in a Jupyter notebook, for example, it would print what the output is. So that's how you want to think about this. So what we're doing in the doc string is saying this is the output that we expect from factorial 30. And when it runs this, if it gets something different, it's going to raise an exception. And we can do this, of course, with more complicated things. Here's a list that we're looking at, even checking that it raises an exception of some kind. We would just try to match what that exception would look like in the terminal. We can use this ... notation as kind of like a wildcard, just match everything. And then there's a third line there. Okay, any questions? Pretty easy, okay. There are some directives for doctest. So in this case, if I didn't have this directive here, what it would do is it would print the list, but because the list that I'm showing in the doctest is separated by 2 spaces rather than just 1, so this test would fail because the spacing is different. So what I'm doing here is just saying there's a comment and then doctest, and I tell it that I want it to normalize white space. So that way it will normalize this output before it compares to what it gets when it runs the code. So that's a useful one. This ellipsis is also used quite often. And that lets you, like we saw before, you just put this ... and then it only will look at like the beginning and the end. For example, here it's skipping everything in the middle. So let me ask you this question. When do you think it would be appropriate to use DocTest for testing your software versus like writing PyTest sort of tests we were talking about last week? Where do they both kind of fit into our overall testing scheme? And I'll ask a follow-up question. Do you think you can do anything really complicated with this? Yeah, not really. So like it's going to be really hard to have elaborate setup. We don't have that powerful concept of fixtures where we can reuse a lot of setup and other tests and things. So generally you want to keep these pretty simple, but they are useful if you have a simple test that that you can describe this way. It's a good idea to do so. You can also avoid it altogether by not printing anything to the screen. So maybe you're just assigning variables, so nothing actually would get printed as a string. And in that case, you still have a nice example there, but it's not going to be checking your code. If it's like a complicated output, maybe the string representation might change. That would potentially be a good idea. Okay, so how do you run these? Well, we can use our trusty framework PyTest for that. We just have to use -- doctest modules, and then it's going to go through all of our source code and scrape these out and run them. Okay, so some tips. Use a spell checker if your editor supports one. Sometimes there are plugins you have to install. I think VS Code is that way, but definitely better to look more professional and spell things right. Use complete sentences when it makes sense, which is usually. And try to be empathic, and try to be a friend. So think about what you'd like to see in the doc string if you were trying to use the software and do that. It's also, it can look awkward to people at first if the doc string is longer than the code, but that's perfectly fine, especially if your function is doing something sort of complicated. Maybe it's calling subfunctions, though. It might only be a few lines, but it still needs quite a bit of documentation. So don't worry about that. And type hints are good too. They let you reduce a lot of redundancy. I was hoping to do a whole module on type hints because I think it's really fascinating how Python's type system works, but we don't have time for that. So you saw a little bit of an example, and I have some more reading, I think, at the end of the course I could suggest. Okay, so quick understanding check on this. What's wrong with this doc string? There's several things.
There's no description of what the function.
Exactly. Yeah, at the top, it should have a one-line description. It's a terrible name too, right? Not part of the doc string, but yeah, I should name it something better. Anything else? Yeah, second parameter is missing. Again, if this was an ideal public doc string, we probably want to add an example as well. You can also add like a notes section if there's some things you need to be aware of, or you might want to add some references for more information about this. You could add that. Okay, so when do we use a comment versus a doc string? What's the difference here? What if we're trying to we need to communicate something? We're trying to decide if it goes in the doc string or the comment. How would we decide?
Maybe if it's developer facing versus user facing.
Perfect. Yeah. Developer documentation is usually going to be the comments, and then user facing would be the doc strings. Okay. Any other questions on doc strings before we move on? All right, let's talk about a README. So this is your project's elevator pitch or a note in a bottle that you're communicating with someone who stumbles upon your library. It should really be concise. Try not to include too many details. Of course, you want to talk about what it does, but show the code right away. People want to see what it looks like to work with the code. So make sure you have examples front and center in README. You'll want to describe its basic functionality, what it's doing, what kind of problems it's solving, maybe some of the basic approaches without going into too much detail again. And this is kind of the smoke test for me. If I spend 2 minutes reading a project's documentation, I want to see the following things. I want to know if the library might solve a particular problem that I have. or at least what problem it solves, even if it's not my problem. I want to see an example right away. And then I want to know if the code is well used and well maintained. And a lot of times that's communicated through badges. You've probably seen the badges that say like how much test coverage, how many times it's been downloaded, if the tests are passing, that sort of thing. So those do a good job communicating that. Has anyone had an experience with a terrible README? Probably the worst README is no README, but after that, trying to use a piece of code and there's no README, so you're not even sure where to start, right? Okay, so project documentation is going to be the kind of the third level here that we're talking about. And this is really to supplement and explain the code base. It's not going to be attached to the code base like comments and docstrings are. These are typically written in REST files, maybe Markdown, sometimes notebooks. Notebooks work pretty well for this. This is typically consumed as HTML or maybe a PDF. So you'll have some other program that will compile it into that. And this should include, for example, your README, some tutorials, technical references, how-to guides, and several other things. And really structuring these in a concise way is very difficult, concise and approachable, because when you're writing this, you wrote the software, you know how it works. So it's hard to put yourself back into a new person's mindset, what they would want to see and know. So there's an interesting framework that I saw a talk for given at PyCon a couple of years ago. But basically, how you look at describing documentation for a project is divided into these 4 quadrants. So on the x-axis, we have documentation that serves for our study. So it's not really teaching us how to write code, but maybe teaching us more about how the code works or some theory that the code is using. And then on the right of the x-axis, it's more about something that will serve your work. So how do you do something specific with the code? And then the y-axis, the positive here is more practical steps, and then theoretical knowledge is the negative y-axis. So I'll just go through and talk about each of these, but if you can sort of put your mind in this framework when you're writing documentation and decide what kind of documentation you're writing, that helps make it more focused. Okay, so tutorials are going to be based on going through a certain number of steps, like following a recipe. They're really useful for new users. They're going to provide a complete picture from like start to finish, how you're using the software. You also want to make sure that you put particular emphasis on testing that this is always working in your main branch, because nothing is going to make your users lose more confidence in your software than if they're going through a tutorial and it doesn't work. Okay, you want to have something where the users can see results immediately. People who are using the tutorials probably are still not sure if they want to use the software, so you want to just make it as easy, user-friendly as possible. We're describing concrete steps here, not like abstract ideas. We might have links to other documentation that's describing more details, but we really want to just keep this short and concise. And then again, only offer the minimum necessary explanation, add links if you think there's more explanation that could be beneficial to some users. And we're not going to go through like all the different options and the different ways of doing it, just show one way that works, maybe the best way in your opinion. And again, talking about different ways of doing it would be another documentation segment. So how-tos, this is kind of like the tutorials, but we're actually solving a particular problem, maybe a more realistic problem. Tutorials might have more toy problems just to show you how to get up and going. Again, though, here we're not going to explain concepts. We're going to add links to other documentation for that. This should be fairly flexible, something that users can adjust. So for example, you probably want to put all the variables at the top so someone could change them easily instead of hard coding everything in a how-to. That way someone can copy and paste the code and it might work for their case, right? Omit unnecessary info, and these should of course be well named. How to do X, where X is a very descriptive thing. Okay, references. These provide technical descriptions of the machinery and how to operate it. So if you've ever Googled like NumPy mean or whatever, this is going to be the page that pulls up. So this should be consistent with the code. When the code and the documentation diverges, again, it makes for a terrible user experience. It should just, excuse me, it should describe the code, provide examples, should be accurate. And this is the important thing. One hardly reads a reference. It's more for consulting. Like you wouldn't sit down and read this from cover to cover. You're just looking for one specific piece of information you need to do a specific task. And the most common would be API documentation. So taking the doc strings that we talked about, transforming those into HTML pages somehow, that would be reference. Okay, and lastly, explanation. This is really where you're not going to talk so much about how to use the code, but maybe why the code is doing what it's doing, maybe talking more about theory, providing some background that users might need, for example. So this will make connections with other, maybe other libraries or other concepts, provides context for what you're doing. Talk about the subject. This is where you'd want to talk about alternatives. So like there's this approach, but there's this approach. We chose this approach for this reason. That's where this type of thing would belong. And then again, though it doesn't overlap with these other documentation types, we're not going to provide technical reference here. It's more theoretical to improve the user's understanding of the theory or why the software is doing something the way it does it. All right, so my advice on this, try not to cross the streams. So keep something really concise and focused on what it's supposed to be doing, and then just add links where you think it might be needed or useful. Ensure that the code is always executed when you build the documentation. You want to make sure you don't have code that won't run in your documentation, again, because that'll make users lose confidence in your software. It helps to have someone who doesn't know the library, who hasn't written the code like you have, review the documentation, see if it makes sense to a new user's perspective. And here's a few of the building tools you can use to create HTML or PDFs. So by far the most popular is Sphinx. It's been around for, I think, more than a decade. Another contender is MKDocs. It's gaining some popularity. And then my personal favorite is this third one. It's actually a newer library, but it does a lot more than just documentation for projects, and it's called Quarto. So that's actually what I built this web page in and all these presentations. It's really powerful. So once you've gotten a tool that builds your documentation into HTML pages, there's several options for hosting. Read the Docs is popular. GitHub Pages is free. It comes with GitHub. It's quite easy to use. So that's what I typically use. If you need more configuration though, maybe you want to like have users sign in, or more complicated web setup type things. Netlify is a good option, and there's several others. Okay, I am going to skip this. So we were going to take a look at some documentation pages, but I really want to cover context managers and generators. So we'll come back to this if we have time. But before we switch gears, overall, what do you think of that documentation framework? What do you think, Hafiz? The Ataxis. I went through it kind of fast. Let's go back to the graphic just so we can absorb it a little more. Right here. I mean, technical writing's hard. It's hard to write documentation. I don't think this is perfect by any means, but I think it helps structure things. But yeah, what do you think?
Is this is all these four supposed to be provided for every like if you're doing an open source software, you think each of these have to be covered? It's should
or must, yes. Exactly. So my take, if it's a small library and you can pretty much introduce everything it does in the README, yeah, you don't need any of this really. You just have a README. But when it becomes a bigger project, then it does need something like this. So we're talking NumPy, Pandas, OBSPy, these bigger libraries that need this type of documentation. Maybe not something you would release with your research code, or if you just have a small utility library that you can show everything it does in a README. The README is not very long. Yeah, you don't need it.
What about for some of the documentation where you show things like a graph of dependencies between different classes? Am I thinking about this right, that it would fall into the category of a reference more than anything else, like an explanation?
Yeah, okay. Yeah, class hierarchy. Now, if you wanted to describe why you designed it that way, that would probably be an explanation, but you would just add a link to that from your class hierarchy. Yeah.
How common is the likely to have the explanation? Like, I feel like I haven't seen a lot of that.
Right, yeah, that's probably the least common, or what happens is it gets kind of scattered throughout everything else. And so maybe when you're going through a tutorial, you have this 3-paragraph break where they're explaining an FFT to you, and it's just kind of distracting. So I think it is fairly common, but it's not common that it's kind of its separate thing, and I think it should be more often. Now, the right way, like we said, if you're going through, first we're going to perform an FFT, then you would just have like a link in that FFT, so it would look blue, you can click on it, and that would take you to more explanation if you wanted to include it.
So what about like examples, separate scripts that you can find on that?
Yeah, I think that is probably either a tutorial or a how-to guide, depending on how specific it is. And if you're trying to teach like the basics of the software, it would be more of a tutorial. If you're trying to solve a very specific problem, maybe it's a little bit longer. That's more of a how-to or a recipe.
Yeah, because mostly I see like README file and that kind of tutorial or examples.
Yeah.
Or like small package.
Right. Yeah, and I think that for a small package, the README file can contain kind of all of these things, but it just shouldn't be too long. If it gets too long, you need to kind of break it up. Okay, cool. Let's switch gears here and go over and talk about some of the really cool Python abstractions called generators. So I think I tacked that on to functional programming. Generators, okay. Okay, so generator is essentially a function that rather than destroying all of its memory and the variables that it had, it's going to pause, suspend its state, and then you can resume it later. So when you see return, everything that was in that namespace is gone. When you call the function again, it's going to create new variables, new memory. But for generators, not the case. And what is going to clue you off to a generator is it's going to be using the yield keyword rather than return. So this is really useful for memory conservation. You can actually have infinite generators. You can't have an infinite list, say, because we don't have infinite memory. But because these can be lazy, that's how that could work. They are capable of two-way communication. So rather than just putting something in, getting something out, you might put something in and then send something back in and get something out. So it's like this back and forth. And that's actually the basis of Python's asynchronous programming model. I'll show an example here in a second. It implements the iterable and the iterators protocol. And so let's take a look at what that means. So I'm going to first show you what an iterable is. So here we have our generator, and this doesn't have any input parameters. It's going to start with value equals 0, and then it has this infinite loop. So while true, it's going to add 1 to the value and then yield that value out. And then what happens when we try to get the next value is it's going to resume at line 5. It's going to go back to line 3, check that while condition. True is still going to be true. And so it's going to add 1 to value and then yield 2. And it will just keep going. So we initialize the generator just like calling a normal function. And this returns a generator object. So that can be kind of confusing if you see an error, like if you thought this was a list, for example, and you tried to access the first element. This raises an error because generators don't work that way. They're more stateful. You can only access the current element, not any element in the sequence. So what it means to be iterable is that you can do this for value in thing, print the value or do whatever you want with the value. When is this going to stop? For our example here. Probably what will happen is it will stop when Python creates an integer large enough that it fills up all of your memory and crashes the program. Could take a long time, I don't know. Okay, so that was, so what we call an iterable is something we can do for X in thing. That's iterable. Iterator is a different protocol, and how we use it is like this. So we have our generator again, same thing from before, but this time we can call next. And so what that will do, it will resume the state of the generator, and then it runs it until it yields again, or it returns nothing. In that case, it's exhausted. Does that make sense? Okay. Now, when you finally do run out of things to iterate through, in this case, we won't run out, but pretend this was only 4x in range 10, for example. Then when the iterator is done, if I try to call next on it, it raises a special kind of error called stop iteration. So that's how you know it's all out. Okay, yield from is a way that you can essentially compose generators together. And so if we have this generator here, it's going to yield some iterable we put into it. Okay, so imagine we have our input list. I think I have, yeah. We have our input list of 1, 2, and 3. And then we're going to call next on the generator once we initialize it. So what is going to be stored in this variable? Okay, so let's walk through it. Generator 0, we give it the input list, so that's going to create our generator object. And then we call next on it, so it's going to advance until it gets to a yield and return whatever that yield thing is. So what do you think this will return? What's going to be stored in 1L?
The whole list.
Exactly. Yeah. So that's going to be the whole list. Imagine though, for example, we actually wanted to return just one element of it. So here is one way we might do it, because, nope, actually this is going to return the whole list as well. And this will be the whole list as well. So these two are kind of the same. What we're doing here is we're explicitly going through each element in the iterable that's returned by that generator. But down here, we're calling list, which implicitly, when you give list a generator, it's going to go through each element and store it in a list. Okay, so here's another example where we're doing something similar, but this time we have our iterable, which is our input to our generator 1, and then we're going to iterate through that for A in iterable yield A. So let's go through that. This is the same line as before. What is going to be stored in 1L? Yeah, exactly. So in this case, we're actually going through the iterable and then yielding out each of its elements. And similar idea here and here. So then the idea for this yield from keyword, which is what I'm trying to introduce here, is that these two are equivalent. It's just line 6 is much shorter. And this lets you compose these generators together and sort of drive them one element at a time. Okay, and this, here's okay, we've got a couple minutes. This is a little bit more of an advanced topic, but like I said before, these aren't just for yielding out values. You can actually send values to them. You can communicate back and forth. And so how this would work, we have our generator here, but this time, rather than just yield value, we're assigning something on the left-hand side. And so how this will work, we'll run this, it'll yield the value, and then whatever we send back into it, that will get assigned to the variable on the left-hand side. So in this case, let's go through. We start with 0, and then we go to the next value. So first is actually going to be what? Maybe this is kind of obscure. Okay, so we initialize generator with 0, so it's going to get that for its value up in line 1. Then we say, well, true. What's going to be the first yield that it hits? What's going to be the value of our key or parameter name value?
There.
0, yeah. So first is going to be 0. Now in out 1, we're sending in 10. So when this resumes, we can substitute that whole yield value with 10, because that's what we're putting back into it. And then that will get added to value. And then it's going to yield again. So what would out 1 be? 10, yeah. And then 5, essentially we're just summing up numbers here. Out 2 is going to be 15, out 3 will be 17. Yeah.
So what if we don't do the same? What if we just do next? Hydra,
Yeah.
will it just be 0 forever or like?
Good question. It's either going to stay 0 or it's going to be none, or it might raise an error. I'm not sure. Let's look into it after class. Okay, so why I spent so much time on generators. This is a little bit probably obscure for what scientists typically do. But if you ever get into asynchronous programming with Python, these are the building blocks. This is essentially how it works. And that's really common for doing IO bound tasks. So hopefully that's a somewhat decent introduction. Okay, but the reason I spent time on the other parts of generators is these are really everywhere in Python. So like if you do mydict.items, that's a generator. It's going to return 1 element at a time. If you try to do mydict.items 0, it's going to raise an exception and say generator objects have no get item. We also can do these generator comprehensions. So we saw list comprehensions. These are just like that, but they're going to be lazy, right? So they're going to evaluate 1 element at a time as you iterate through them. So these are fairly common as well. Okay. Any questions about generators? Can you see why they would be useful? So I'll give you an example. One library I was working on a while ago, I needed to collect a bunch of information about files that were in a particular directory, and there were millions of files. And so what I was doing at first was just collecting that into a list. It became a very, very big list, and it took a long time. But when I swapped it out for a generator, it just gave 1 file at a time. And then that time that it takes to find more files is pretty much just nothing, right? We're just finding 1 at a time, doing something, and then moving on to the next. So whenever you have very large lists or potentially infinite things you need to iterate through, generators are the way to go.
So, like this libraries like Ray does use this kind of concept to work with lazy evaluation.
So they have like promises. It's a different structure, but it's basically like you have an object that says, I'm going to calculate this thing eventually, but it's not done yet, and it just represents a placeholder. It's a similar idea, but it's not quite the same. Yeah, because you might spin up a separate thread to do the computation or a separate process, and then it lets you know when it's done. So we could look at some of those libraries, but I think they're mostly promise-based or like MapReduce based. Okay, and the last thing, context managers. So these are pretty easy. We can just think of these as generators, and these are also all over the place. So it's very useful when you need to set up or tear down some kind of context or prepare something before you do it and then clean up something afterwards. Probably the most common case is for files. Hopefully you've all seen this with open some file, and then you get a file handler and you write to the handle. So these are actually quite easy to write. So you just import context manager from And then everything that happens, let's see, I think I highlighted it, yeah. So we have the decorator, we have our function. So we're gonna do our setup here. Yield is gonna be whatever you assign to as the as variable. So in this case, with open, my open test file as phi, whatever phi is there gets yielded out from the generator. And then when it's all done, this is gonna get called even if an exception is raised. There's also a way to do this with classes, which is a little bit more flexible, but it's also more complicated. So typically try this first, and then if you need like more complicated exception handling, there's a way to do it that you can have more flexibility. Okay. So that's everything. Hopefully we learned something. Speaking about context managers, has anyone seen another example besides just file writing that you've run into? So something else besides opening or reading a file that uses the with keyword to start. Any examples? Okay. You do see it a lot when you have some kind of persistent connection with a database, for example. You might see it when you are running a test. We saw this in PyTest. We had with pytest.raises. That was a context manager. So yeah, they're used quite often. You'll start to see them more now that I think they've been formally introduced. Great. Any questions on anything we covered today?
Just looking at this like documentation now, I want to see like if it shows up there.
Yeah, I think, so if you look at SQL Alchemy, there's a method where you have a context manager, you describe all the changes you want to do. And then when the context manager exits, it actually commits it to the database or performs those transactions. That's pretty common. Okay, great. So next week, we're going to talk about project structure. And so I'll talk about how do you structure a Python application, a Python library, and then finally some of the research repos that we're interested in publishing. So I'll ask each of you to kind of come prepared, ready to discuss how do you structure your research code. As I found researching it that there's certainly not a generally accepted best practice there. There's many different ways of doing it. Okay.